We have an example problem here. Two metal spheres are the same size and mass, but sphere 1 has a charge of -2 nanocoulombs, and sphere 2 has a charge of +4 nanocoulombs. The spheres, that's a typo, sorry, the spheres are put in contact with each other. Which sphere do electrons move from and to? How many electrons are transferred? All right, so our spheres, sphere 1 has -2 nanocoulombs. Sphere 2, same size, same mass, is +4 nanocoulombs. When they are brought in contact, because they are metal, they're good conductors, this contact allows the valence electrons, the outside electrons, to move around. Now, they're going to move until an equilibrium has been reached. We call that an electrostatic equilibrium. Well, it's only electrons that can move, and so electrons are going to move from the negatively charged sphere to the positively charged sphere until there is an equilibrium. All right, so the total net charge, just in general, is going to be the -2 nanocoulombs plus the +4 nanocoulombs, so +2 nanocoulombs. Now, in electrostatic equilibrium, the excess charge ends up spread uniformly over the surface of the conductor. That means because these two spheres are the same size, both of them will end up with half of this. So we can say that both spheres end up with a net charge of 1 nanocoulomb. If the spheres were different sizes, they wouldn't end up having half. So if one was bigger than the other, the charges would end up distributing, the electrons would move around until the charges were equally spaced on these surfaces. We say they would have the same charge density. We call it specifically a surface charge density. So the charge per surface area would be the same. We'll talk more about that later. Right now, because the spheres have the same size, they both get half of whatever the overall net charge is. All right, so A, the electrons move from wherever the charge is most negative, so they move from sphere 1 to sphere 2. The electrons are going from negative to positive. Okay, B, how many electrons are transferred? Okay, so sphere 1 starts at a -2 nanocoulombs, but ends up at a +1 nanocoulomb. To go from -2 sorry, writing and talking are hard to do at the same time sometimes. The charge on sphere 1, Q initial, is -2 nanocoulombs. the charge ends up at 1 nanocoulombs. So the charge has changed. Remember, we always take final minus initial. So this charge has changed by 3 nanocoulombs. And so essentially, we just have to figure out how many electrons that is. So the number of electrons is going to be this charge. And then we need to use the fundamental unit of charge. We know an electron is 1.6 times 10 to the negative 19 coulombs for each electron. Now, I'm not accounting for the electron being negatively charged. I don't need to do that in terms of just finding out how many move. So 3 times 10 to the negative 9 divided by the charge on that electron. My calculator's telling me this. 1.875 times 10 to the 10th coulombs. But coming back to the problem, the values we are given, the 2 nanocoulombs and the 4, are in terms of 2 sig figs. So I need to round my answer to 2 sig figs. And that is so not the units of coulombs. I apologize. This is the number of electrons that move. 1.9 times 10 to the 10th electrons move from sphere 1 to sphere 2.